With lesson 4.1, identifying linear functions. You were supposed to have SQ3R this lesson, so I'm not going to begin to cover everything with you in these notes that's in this lesson. So hopefully you have good notes, or you need to add to your notes, and you need to make sure that you study this lesson on your own also. So let's start with, an equation is linear if x and y both have exponents of 1. Or in other words, they're just x to the first power and y to the first power, which typically, when something is to the first power, we just don't write that exponent. It's linear if x and y are not multiplied together. So x's and y's can be getting added in an equation, but if x is being multiplied by y, then it is not linear. And then there's three things that x and y, neither of them can appear in. They cannot appear in a denominator. So x or y can be in a numerator, but not in a denominator. Or in other words, we can't be dividing by x or y in the equation. They cannot appear in an exponent. So we can't have something being taken to a power where x or y are in that exponent, in that power. So we can't have like 3 to the x power. That would be not linear. And then last but not least, x and y cannot appear under a radical sign. And a radical sign is as such. So if they're underneath a radical sign, either the x or a y, that disqualifies that equation as being linear. So those are the things we're going to look for when we're deciding if an equation is linear or not. These disqualify it from being linear if any of these things happen. Not all of them have to, just one of them, and it's not a linear equation. The other thing that we do with linear equations, there's different forms we can write it in. In this lesson, we're going to talk about standard form of a linear equation. So standard form, algebraically, looks like this. Capital A, little x, capital B, little y, equals capital C. So ax, x is being multiplied by a constant, plus by, y is being multiplied by a constant, equals c, c is a constant. But we have to say where a and b are both not 0. If we had 0 for a and 0 for b, we would not have any x's or any y's, and therefore we'd not have a linear equation. We need to have at least one of them, either some x's or some y's, or maybe both. So what we do is we're going to learn how can we write an equation in standard form, because there are times it is useful for us to have it that way. So let's do some practice. If linear, so once you decide the equation is linear, then write it in standard form and identify the a, the b, and the c. So we have 5x minus 2y equals -3. Let's run it through the tests. Are both x and y to the power of 1? Even though it's invisible, yes they are. It's 5x, x being to the first power, minus 2y, y being to the first power, equals -3. Passes that test. X and y, are they being multiplied together? No, y's are being subtracted from x's, but there is no multiplication going on between the two. Do either the x or the y appear in a denominator? No. Do either appear in an exponent? Is anything being taken to an x power or a y power? No. And are there any x's or y's under radical signs? No radical signs involved in this equation. So we're going to say that this equation passes the test, so it is linear. Okay, now it says if it's linear, write it in standard form. Well, in reality, I'm going to erase those little powers of 1 because we know they're there, that we don't typically write them. In reality, it is in standard form, but it's just been cleaned up. So what's standard form, if we want it as ax plus by, we have 5x, change the subtraction to add 2y to its opposite, so we'd have negative 2y equals negative 3. So there's standard form, just not cleaned up. And we would be able to say then that, what's our a value? A is what x is being multiplied by, so a is 5. What's our b value? B is what the y's are being multiplied by, negative 2. And what's our c value? Our constant on the other side of the equation, negative 3. So here we've written the equation in standard form and identified the a, b, and c. Okay, let's go on to number 2. We decide if 4y equals x over 2 plus 5 is linear or not. Well, does it pass all the tests? X and y, are they both to the power of 1? Again, this is y to the first power. X is to the first power, so it passes that test. How about, are they being multiplied together? No, we have y's on one side of the equation, the x's are on the other side, they're not being multiplied. Do either of them appear in a denominator? No, the x's appear in a numerator, but they're not in a denominator. Are either x or y as a power, as an exponent? No. And last but not least, are either of them under a radical sign? No radical signs in that equation. So we are going to say it passes the test of being linear. Is linear. Okay, is this one, though, in standard form? In other words, are the x's and the y's together on the same side? And they're not. So one thing that we like to typically do, I'm going to get rid of these exponents. One thing we like to typically do is we want the a value to be an integer value that is actually a positive number. So if we can, we try to get a to be a positive, basically a natural number, a counting number. So since x is being divided by 2, I think the first thing we're going to do in this is we're going to take every piece of that equation times 2 to get that fraction out of there, to eliminate that denominator. So we'll take 2 times the 4y, we'll take 2 times the x over 2, plus we'll take 2 times the 5. So remember, whenever we multiply or divide in an equation, we do it to every piece. Okay, now we have 2 times 4y, we have 8y. When we take 2 times x over 2, those 2's cancel, we have x, and 2 times 5, 10. Okay, now remember what I said, we want the a value, what x is being multiplied by, to be a positive integer or a counting number, a natural number. Right now it's 1. There's an invisible 1 here in front of our x. So we're going to leave the x on that side because then it will stay positive, and instead we're going to move the y's over to that side with it. Let's start with that. Let's move the y's over. Subtract 8y from both sides. Now we have 0 equals x and plus 10 and minus 8y. Okay, now we get the x's and y's together on the same side. What we need to do now is get that 10 moved over so that constant is by itself on the other side to be in standard form. So we'll subtract 10 from both sides. 0 take away 10, negative 10. X, these guys are gone, and we have subtract 8y. So again, this is in standard form. It just might not look quite like standard form because the c is on the left instead of the right. So we'll just have those two expressions trade sides. We'll have the 8x minus the 8y move to the left side, and the negative 10 move to the right side. They're just trading sides. They're equal to each other, so it doesn't matter who's on which side. And then we'll say, okay, it is now in standard form. Let's just leave it like that in nice cleaned up fashion because that's how we would actually see it in an answer bank. And let's see if we can identify A, B, and C properly. So what is x being multiplied by? 1. That subtract 8y, if we did change it to add the opposite, we'd have plus a negative 8y. So our b value is negative 8. Because remember, standard form is plus by. And our c value is negative 10. So there's our linear equation in standard form identifying A, B, and C. Okay, let's go to the back side of the notes. We're still practicing, is the equation linear? So we have x minus 2 over 3 equals y plus 1 over 5. Run it through the tests. Are x and y both to the power of 1? Yes, they are. Invisible, but they are. Are x and y being multiplied together? No, they're on opposite sides of the equation. Do they appear, either of them appear in a denominator? No, just so happens they're both in a numerator. And do they have, are they as an exponent on anything, x or y? No, they're not. And are there any radical signs in this? There are not. So we are ready to say this is linear. And I'm going to get rid of these just to make it look a little better. Okay, this is a proportion. We have a ratio set equal to a ratio. We can dig back in our reservoir and say when we have a proportion we can do cross products. So we can take 5 times that x minus 2, we're doing cross products, and set that equal to the other cross product, which is 3 times y plus 1. Now we'll simplify. We'll do our distributive property. So we have 5x, subtract 5 times 2, 10. Take 3 times y, 3y, plus 3 times 1, 3. Okay, remember standard form. We like a to be a positive whole number, counting number actually. So it's 5 right now, we like that. So we're going to let the 5x stay where it's at. We're going to move the y's over to be with it, with those x's. And we have 5x, take away 10, take away 3y, because really none of those are like terms to be combined, so they have to hang out together like that. And these cancel, and we have just 3 on the right side. So we're getting closer to having it in standard form. Now we need to move that 10 out of there. So we need to add 10. It's being subtracted, undo subtracting with adding. We'll add 10 to both sides. And we have 5x gone minus 3y equals 13. So we have it in standard form. So there's our standard form. This is how we would see it in an answer bank when they ask us for standard form. Now we just need to pick out what our A value is, our B value, and our C value. So our A value, what our X is being multiplied by? 5. B value, Y's, if we changed it to add the opposite, it would be plus a negative 3Y, so B is negative 3. And C is 13. Okay. So another linear equation, just renamed in standard form. Same equation, just a different name for it. Okay, let's look at number 4. Number 4, linear. We have 3xy equals 6. I see right away it does not pass the test of x and y being multiplied together. So we're going to say not linear because we're going to give our reason. X and y are being multiplied. They are factors in this, both of them, not linear because x and y are being multiplied times each other. So remember, it only has to fail one of the tests, and that's the test it fails for being linear. Okay, and how about number 5? 4x equals negative 8. Okay, so pass all the tests. X is to the power of 1. X is not being multiplied times a y. X is not appearing in a denominator. X is not in an exponent. X is not under a radical sign. Passes all the tests. Probably right now you're feeling like, how can it be linear because it's missing the y's? Remember, it does not have to have both the x's and the y's. It said, back in the front, we said, where A and B are both not 0. So it didn't say one of them couldn't be. So in this case, the B value is actually 0. It wiped out the y's. So when we can say this one is linear because it passed all the tests. And even though it doesn't have a y, any y's, that doesn't matter. That wasn't one of the tests. And the x's are by themselves. The constants on the other side. This is already in standard form. Excuse me. So we're ready to identify what our A, our B, and our C are. A is 4. There are no y's, so that means y got multiplied by something that wiped them out. Multiplying by 0 creates 0. That'd be 0 y's, they're gone. And C is negative 8. Okay, so this is all we're going to practice together. Doesn't mean it's the only thing you will do in your homework, but you have your SQ3R. You should have already studied through this lesson, or you can continue to study the examples in the book and the book to help you out also. Okay, good luck.